Hello everyone, welcome to MindMatrix. So in this video, we will be solving all the questions from set 1 of digital logic subject. That is from GATE 2024 exam. Okay, so we are going to provide you the solutions for each and every question from all the subjects, that is from both CS set 1 and CS set 2. So we are going to provide you the best solution and you will be able to understand each and everything. So without waiting, let's start. And before starting, let me introduce myself. Those who are new to our channel, my name is Anshul Sharma. I'm upcoming software engineer at Juniper Networks. Currently, I'm pursuing MTech in computer science from IIT Kanpur. I have 2+ years of experience and I have mentored more than 1,000 students as of now. I have the expertise in computer science and data science subjects. Secured All India Rank 294 in GATE Computer Science, cleared ISRO NIC NILET exam, and also got selected as Administrative Officer at AIC. These are our premium courses. So many students have already enrolled and live classes are going on for both GATE Computer Science and for GATE DA as well for 2025 and 2026. Also, we are providing as a combo as well. That means in the combo, you will be getting both GATE Computer Science and GATE DA. So without waiting, you should enroll in it and start your preparation for GATE 2025 and 2026 if you are a GATE aspirant. You can visit our website www.mindmatrix.net.in. Okay. Also, you can apply the code RISE30 to avail 30% discount, flat 30% discount on all our premium courses. And this offer is valid till 25th. Till 25th Feb. Okay, fine. And if you want to check the content quality that we are providing, so you can enroll in my operating system course. So I'm teaching this operating system course and providing you for free. So you can enroll in this. You can visit our website. Also, all the links I will be providing in the description. You can just click on it and you can visit it. Okay, and start preparation. You can also connect with us. This is our public doubt discussion Telegram group. You can join this by scanning this QR code. This is the QR code for our website and this is the QR code for our WhatsApp channel. Fine, so that you don't miss any notifications and updates. And also subscribe to our channel for more such videos and all the updates related to GATE Computer Science and GATE DA. We will be providing you on this channel only. So this is the first question that we have from digital logic subject, and this is from CS set 1. So let's try to solve this question. Carefully read the question first. Consider a system that uses 5 bits for representing signed integers in 2's complement format. What are signed integers? That means they can have negative and positive value both, right? Unsigned integers means they can have just positive values. Negative values are not, are not allowed. So signed integers it is talking about, and it is of 5 bits, and it is in the 2's complement format. Fine. In this system, two integers a and b are represented as, so value of a is given, value of b is given. Which one of the following operations will result in either an arithmetic overflow or an arithmetic underflow? That we need to find out. These are the operations given to us in the options, and we have to find which one will give us overflow or underflow, that is arithmetic based. So we know this, that the numbers given to us are in the 2's complement format. So we know the range of 2's complement format is -2 raised to the power n minus 1 to +2 raised to the power n minus 1 minus 1. This is the range of 2's complement numbers, where n is the number of bits. N is number of bits. Here in this question it is given that n value is equal to 5. So what can be the range? What will be the range if you substitute n is equal to 5? The possible range using 5 bits in 2's complement format will be minus, if you substitute, that is 5 minus 1, that is 4. So minus 16 to, this is going to be 16 minus 1, that is 15. So minus 16 to plus 15 will be the range if you have 5 bits in 2's complement format. Okay, now here if you see, we are given the this two integers a and b. A is 0 1 0 1 0, right, and b is also given to us, which is 1 1 0 1 0, right. So now we need to perform these operations and need to find which one will give us the overflow. So a is given as 0 1 0 1 0. This is nothing but 10, right? You can easily calculate This is in 2's format. The most significant bit is 0. So 2 raised to the power 0. This is 2 raised to the power 1. 2. This is 2 raised to the power 3. So 1 into 2 raised to the power 3, that is 8 plus 2. It is going to give you 10. Fine. What about b integer? So it is 1 1 0 1 0. So this is 2 raised to the power 1, 2, 2 raised to the power 3, and this is most significant bit is 1 here. So it is going to be minus of 2 raised to the power 4. So what do you get? Minus 16 plus 8 plus 2, and that will give you minus 6. So this is the value of b integer in decimal if you talk about, right? Now we need to perform these operations, so let's do it. So here in the first option we are performing a plus b. A plus b will give you what? 10 plus of minus 6 will give you 4. A minus b, so 10 of minus 6 will give you what? This is going to be plus 6, so it is going to give you 16. B minus a, minus 16 minus 10 will give you minus 16 here, and twice of b, so twice of b will give you what? Minus 12. This is what we are getting now. Now carefully see here, we need to find which one is giving us the underflow or overflow. So 4, result of first one is 4. 4 is lying in this range? Yes it is. So there is no overflow here. There is no overflow here, there is no underflow here. What about option B? 16. Is 16 present in this range? No. The maximum positive value we can have is 15 using 5 bits in 2's complement format. We are getting 16 here. So definitely this is overflow. This is overflow here. What about option C? B minus A, minus 16. Yes, minus 16 is present in this range, so no overflow. And option D, minus 12 is also present in this range, so no overflow. Option B is the correct answer for this question. Okay, so I hope it is clear. And how to solve these questions, I hope that is clear to you. Let's proceed to the next question now. Now here we have the second question, and let's try to read the question first. Consider the circuit shown below where the gates may have propagation delays. Okay, so the gates we have, they can have the propagation delay. Assume that all signal transitions occur instantaneously. That means all signal are transferring instantaneously without any delay, you can say. And the wires have no delays. Wires are also having no delays. That means only gates may have the propagation delays to transfer the signal that is present here. Which of the following statements about the circuit is or are correct? That means this is MSQ question. More than one may be correct. Okay, so this is given to us and we have to find which one is correct. So here if you see the option just once, here it is saying with no propagation delay this can happen. You have to find whether it is correct or not. And when it is propagation delay, then what can happen, right? So that you need to find. So in first case, we will consider that there is no propagation delay, and then we need to find whether A is correct or not, whether B is correct or not. And when you are considering propagation delay of a gate, then whether C is correct or not and whether D is correct or not, that you need to find out. I hope it is clear to you, right? So let's try to solve this question. Let's try to solve this question here. So in option A, it is saying with no propagation delays, the output Y is always logic 0. Okay. With no propagation delay, the output Y is always logic 0. So here if you see, let's try to find out. Let's say there is no propagation delay as per the option A. Let's say I'm giving X value as 0. There is no propagation delay, so obviously here I'm going to get 0, and there is a NOT gate applied here. There is a NOT gate applied here, so 0 will become 1 because we are not considering any delay of a gate here, and we are performing AND operation. So it will give me what? AND operation, 0 and 1. 0 and 1 will give me 0 only. So in this case, I'm getting 0 as the output. Fine. Now let's consider when X value is 1. When X value is 1. Okay. When X value is 1, then we need to find whether we are getting 0 or not. So in case of 1, this will become 1 and NOT of 1 will become 0. Again, 1 and 0 will give me what? 0 only. That means in both the cases, it doesn't matter if there is no propagation delay of these gates, then definitely always we are going to get 0 in the output. Always we are going to get a 0 in the output. So can I say option A is correct here? With no propagation delays, the output Y is always logic 0. Whether the value of X is 1 or 0, always it is going to be 0. So option A is definitely correct here. Okay. Now let's try to see the second option here. Second option says with no propagation delay, the output y is logic 1. That we have already proved. It is always going to be 0. So definitely option B is incorrect here. Now let's see option C and D. They are very important to understand. With the propagation delay, now we are considering the propagation delay. The output y can have a transient logic 1 after x transitions from logic 0 to logic 1. Now there is a term used here, that is transient. Transient means temporary. That means for temporary amount of time, it is going to hold some value. Just for temporary, it is not going to be permanent. Okay, so transient means for temporary amount of time, it is going to hold the value. Clear? Now let's try to solve this question. So we are considering propagation delays here. So let me just erase this one now so that we can reuse this figure. Fine. Yeah. Now we are considering that this gate is having some propagation delay. Let's say this gate is having a 1 nanosecond of delay. 1 nanosecond of delay, just for example. Let's say the value of x is 0 initially. So in the option it is saying that when after x transitions, that means after x changes its value from logic 0 to logic 1, y can have transient logic 1. So let's try to find out. So x is having value 0. So if x is having value 0 and we are going to have 0 here and there is 1 nanosecond delay, fine. After 1 nanosecond delay, we are going to have 1 here because there is a NOT gate applied here. What value you are getting here? Can I say I'm getting 0 here? Fine. Now we have to see when I make a transition for x from logic 0 to logic 1, what can happen. So if I make a transition from logic 0 to logic 1, so I'm going to change the value of 0 to 1 instantly. There is no delay in this one, right? In this one there is no delay because wires are having no delay. So directly it is going to replace the value by 1. Directly it is going to replace the value by 1. But this NOT gate is having propagation delay of, let's say, 1 nanosecond. You can consider any value, but there is some delay, right? So it will take 1 nanosecond more to reflect the value 0 here. To reflect the value 0 here. So can I say when we are considering this delay, then the value of this y output, final output, will become 1 here because 1 and 1 will give me 1 now. Right? And then after 1 nanosecond, it will settle down and 1 will become 0. 1 will become 0 after 1 nanosecond of delay. Right? Then in that case, what will be the output? It is going to become 0 now. So is it true that with propagation delay, when you are considering, there is a transient just for some amount of time, you can say, let's say for 1 nanosecond, there was the value of y was 1, logic 1. That means this was a transient. Just for temporary amount of time, the y value became 1, right? And then after that, when we are considering this delay, that means after 1 nanosecond, this value becomes 0. And then finally, again, we are going to get 0 here. Again, we are going to get 0 here, and it is going to be permanent now. So just for some transient, that means for temporary amount of time, the logic y became 1. So can I say when we are considering propagation delay, the output y can have logic 1, transient logic 1? That was true. We have seen it already. When x is making a transition from logic 0 to logic 1. So option C is definitely correct here. Option C is definitely correct here. What about option D? Option D says with the propagation delay, the output y can have a transient logic 0. Transient logic 0. That means for temporary, it is going to have 0 after x transitions from logic 1 to logic 0. Let's consider this case as well. From logic 1 to logic 0. So I'm just erasing this, everything. Fine. Now, when x is making a transition from logic 1 to logic 0. Fine. So initially the value of x is 1. So here, let's say again we are considering that 1 nanosecond delay is here. There is no delay, so here we are getting 1 here directly, and here let's say we are having 0 because there is a NOT gate. So output what we are getting, 1 and 0 will give me 0 only. 1 and 0 will give me 0 only. Now we are considering the transition. So we are making the transition now from 1 to 0. From 1 to 0, X is making the transition. Instantly this will become 0 because there is no delay in the wires. And here after 1 nanosecond this 0 value may change. This 0 value may change, but we will consider it. But before it, this 0 and 0 will give me 0 only. This 0 and 0 will give me 0 only. Right? Right? And after 1 nanosecond, this will become 1. After 1 nanosecond, this will become 1. And then finally also we are getting 0. So it is talking about this one, this transient. Is it transient here? Now carefully see, here it is saying output Y can have transient logic 0. Is it transient? Is it transient? No, because initially it was 0. Then when you change the value of X from 1 to 0, then also it was 0. And then after considering this delay, then also finally you are getting 0. So is it transient? No, it is permanent. It is permanent. It is permanent. That means the value of Y is not changing. Even if you are making with propagation delays, even if you are making a transition from 1 to 0, the value of Y is not changing. So there is no transient logic change here. It is permanent. So that is why, but here it is talking about transient logic 0. That is why this option is incorrect. Option D is incorrect. The correct answer for this question is option A and C. I hope it is clear to all of you. What is temporary and what is permanent, right? Transient means temporary. Okay. So in this way we have to solve this question. It was a very good question based on hazards that we cover in the digital logic subject, and I cover in a lot of detail. I consider many examples based on this. So like in the paid lectures, if you see, you can watch it and then you can see many examples I have taken based on this. Fine. Let's proceed to the next question that we have from this digital logic subject. Consider a boolean expression given by this function of 3 variables x, y, and z, and we have the set of minterms here 3, 5, 6, 7. Which of the following statement is or are correct? Again, it is a MSQ question. So one or may be correct. One or more than one may be correct. So let's try to solve this question. We have to find whether these are the max terms or not, whether this is the correct expression of this function given, right? And whether it is independent of input y or x, that we need to find. So it is a very simple question. You just need to make a 3 variable k map. You need to make a 3 variable k map here. Fine. So 3 variable k map x, y, and z. It is going to be 0, 0, 0, 1, 1, 0, and 1, 1. And we know this, that this is 0, this is 1. So here this cell belongs to 0 because it is 0, 0, 0, all are 0. So 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. Fine. Now we need to fill the minterms. So minterms are present at 3, 5, 6, 7. 3, 5, 6, 7 are your minterms. So 3 is here. Yes, this is your minterm. 5 is your minterm. 6 is your minterm. And 7 is your minterm here. 7 is your minterm here. Now we need to find the expression. So we can make a subcube of size 2 here. Right, subcube of size 2. This one is possible. This is also possible, subcube of size 2. And this one is also possible, subcube of size 2. Yes or no? Now, in order to find the expression, we know this is your essential prime implicant. What is essential prime implicant? The prime implicant which is having at least one minterm which is not covered by any other prime implicant. So this minterm is not covered by any other prime implicant. So this is essential prime implicant. You have to keep that in the expression. This one is also essential prime implicant due to this minterm because it is not covered by any other prime implicant. And this one is also essential prime implicant. All three are essential prime implicants, right? So what will be the expression of the function? So here non-changing variables for this one, for this first essential prime implicant, both are non-changing variable x and y. So it is going to be xy. Or if I talk about the second essential prime implicant, which one is the non-changing variable? X is the non-changing variable, right? X is the non-changing variable. So we are going to have x here. And Z is the non-changing variable, so we are going to have Z because this second essential prime implicant is lying in when Z is equal to 1. Or if I talk about this third essential prime implicant, which one is the non-changing variable here? Y is the non-changing variable because here also Y value is 1, here also Y value is 1, and Z value is 1, so it is going to be Z. This is going to be the expression. If you see here XY or XZ or YZ, definitely B is correct. Definitely B is correct. What about option C? Independent of input Y. No, it is not independent of input Y because Y is present in the expression. So this is incorrect. Independent of X, that is also incorrect. X is present in the expression. What about max terms? There are no don't cares present here. There are no don't cares present here. So whatever terms which are missing here, whatever terms which are missing in this expression, that means canonical SOP, that means here you have the min term. So whatever terms which are missing, that is going to be your max terms. So 0 is missing here, yes, 1 is missing in this one, 2 is missing, and 4 is missing. So definitely these are your max terms. Max terms, that means those are going to have the value 0 in their cell. So option A is also correct. Option A, comma B is the correct answer for this question. Is it clear? So let's proceed to the next question now. Let's try to solve this question that is based on combinational circuits, multiplexers. Consider a digital logic circuit consisting of 2 to 1. So this is also 2 by 1 multiplexer. This is also 2 by 1 multiplexer. That means 2 inputs, 1 output. And this is also 2 by 1 multiplexer. So 3 2 by 1 multiplexers are given, M1, M2 and M3 as shown below. X1 and X2 are the inputs of M1. So these are the inputs of M1. X3 and X4 are inputs for M2. These two are the inputs for M2. A, B, C are the select lines of M1, M2, M3 respectively. So this is the select line for M1, B is the select line for S2, and C is the select line for M3. B is the select line for M2, right? So this is given to us. For an instance of inputs, when X1 is equal to 1, X2 is equal to 1, X3 is equal to 0, and X4 is equal to 0, the number of combinations of A, B, C that give the output Y is equal to 1, we need to find. So here it is given the value of X1 is 1, the value of X2 is 1, the value of X3 and X4 are 0. Now we need to find the possible combinations. Let me use another color here. Now we need to find the possible combinations here of A, B and C, for which the value, the output of Y, the output Y is equal to 1 here. Okay, the output Y is equal to 1 here. So let's try to solve it. It is very simple question. Now carefully see here. Here if I try to write the equation for this first multiplexer, here A is the select line here. So can I say A complement X1 will be taken as the input, that is 1, or if it is A, then that case X2 will be taken as input, so that is going to be 1. Finally it is going to give you A complement, just a minute, it is going to give you A complement, yes, it is going to give you A bar or A, which is equal to 1 only. So output of this first multiplexer is 1. That means input to this one is also 1. What about this one? So it is going to be B complement, inputs are 0, whether it is B complement or B, both inputs are 0, X3, X4, so it is going to be 0 only. Output of this is 0, here also you are going to give 0. Now let's write the equation for this last multiplexer. So it is going to be, if it is C complement, then it is going to consider this input, which is 1 here, and if it is C, it is going to consider this input, which is 0 here. So finally what you are getting, C complement only. You are getting C complement only, right? So the output is C complement. Fine. Now as it is mentioned that we need to find the possible combinations of A, B and C. What we are getting, it is always giving us C complement. So if it is giving us C complement, that means always the value of C will be 0. That means the value of C is fixed. The value of C is fixed here. Clear? Now, what can be the possible combinations? What can be the possible combinations? That we need to find out here. So here, and the output we are going to get is always 1. The output we are going to get is always 1. So obviously, if value of we are getting y as 1 and c complement, that means value of c is 0, then only we can get the output as 1, because y is nothing but c complement. If the value of c is 0, then only y can become 1, and in the question it is given that y value is always 1. So what are the possible combinations? C value will always be 0. So all it depends on the A and B combinations. So if you have two variables, how many combinations are possible? 2 raised to the power 2, that means 4 combinations are possible. That is 0, 0, 0, 1, 1, 0, and 1, 1. These 4 are the combinations possible, and the value of C is always fixed, that is 0. So these are the possible combinations of A, B, and C. So total combinations are 4. So 4 is the correct answer for this question. And here we can write that as 4. The number of combinations of A, B, C that give the output y is equal to 1 is 4. So 4 is the correct answer for this question. Clear? So that's it from this one. I will see you in the next one, where we'll be solving digital logic questions from another set, that is set 2 of GATE 2024. Fine. You can join us, you can join this public doubt discussion group that we have created. More than 1300 students are there in this group. You can ask your doubts. If you need any guidance, then also you are most welcome. You can join our WhatsApp channel also by scanning this QR code, and you can visit our website www.mindmatrix.net.in. If you really want to prepare for GATE 2025 or 2026, this is the time. Start your preparation now and enroll in the paid courses. Live classes we have already started. In GATE Computer Science, operating system is going on, and in GATE DA, probability and statistics is going on, live classes. Okay, so don't miss out. You can use the code RISE30 to avail the discount, flat 30% discount, and it is valid till 25th of Feb. Fine. So that's it from this video. I will see you in the next one. Till then, take care and bye bye. Thank you all. Bye.